Now, this is physics for class 12. Two beams A and B whose photon energies are this much and this much, respectively, illuminates a metallic surface. Work function it is given to you phi. Successively, the ratio of maximum speed of the electrons emitted due to the beam A to that due to beam B. So you know that K max, that is equal to half mv square. This is equal to Planck's constant into frequency of the incident radiation minus phi, that is work function. So for A, this will be half mva square, that is your energy it is given to you, that is 3.3 electron volt, and work function it is given to you minus 2.3 electron volt, so this will be 1 electron volt. And similarly for B, this will be half mv b square, that is equal to, here energy is given your 11.3 electron volt, work function is 2.3 electron volt, so this comes out to be 9 electron volt. We knew we have to find the ratio, velocity ratio. So here this divided by this divided by this one divided by this, we get va square by vb square, that is equal to 1 by 9. So va by vb, that is equal to 1 by 3. So this is your answer. This is your answer. So here you see two beams A and B whose photon energies are 3.3 electron volt and 11.3 electron volt respectively. That means K max it is given to, not K max, that is the energy of the incident radiation, that is the energy of the energy of incident radiation. First is 3.3 electron volt and that of the second is 11.3 electron volt. So, and the work function is given to you. We have to find out the ratio of maximum speed of the electrons. So we know that the theory, that is K max, that is equal to half mv square, that is equal to h, that is Planck's constant, into frequency of the incident radiation, and minus phi, that is the work function. That means here, this is the minimum energy required for an electron to just eject from the metal surface. So here, all these things are datas are given to you. I just place the data, and va by vb, your answer is 1 by 3. This is your answer. We know that potential energy between two charges, we know this, between two charges, that is k q1 into q2 by r, we know this. So here, say two charges plus q each kept at 2a distance apart. A third charge minus 2q is placed midway between them. So let us take that one charge, it is at 0 position, and this is q, and another charge that is at 2a distance. This is the 2a distance, and here another charge q, and a third charge minus q, minus 2q. It is placed midway between this, so this is a, and this is also a. So your figure is somewhat like this. Now let us take 1, 2, and this is 3. So potential energy between 1 and 3, P1 3, what it will be, K Q minus 2Q, and your distance is A. This. Again, your potential energy between 2 and 3, P2 3, this will also K minus 2Q Q by A. And third is the potential energy between 1 and 2, P1 and 2, that is equal to K Q by 2A. This is your. Now your to system, because the total the potential energy of the system, you add it up. You just add it up. That means minus 2 uh, Q square K by A minus 2 Q square K by A plus, here it will be K Q square by 2A. Just you add it up. So what you are going to get here is that Q K Q square by A is your constant, minus 2 minus 2 minus 2 plus half. So this will be how much? Minus 4 minus 4 minus 8 plus 1 7 minus 7. So your answer will be minus 7 K Q square by 2A. This is your answer. You know that the potential energy between two charges is your formula is K Q1 into Q2 by R. So here this is the two charges are set to, let us take one at 0, another at 2A distance, and in the midway there is minus 2Q. So potential energy between 1 and 2 is 1 and 3, 2 and 3, and then 1 and 2. So you add it up, you will get the potential energy of the system. Here you see, the next question is two identical small conducting balls B1 and B2 are given minus 7 microcoulomb and plus 4, this is plus 4 microcoulomb charges respectively. They are brought in contact with a third identical ball and then separated. If the final charge on each ball is minus 2 microcoulomb, then the initial charges on B3 balls. The theory is that when they are brought, all the three balls are brought together, the charge is equally distributed among themselves. The charge is equally distributed among themselves. That means here the charge is equally distributed among themselves. So your final charge, final charge will be 3. There are three balls, so into minus 2 microcoulomb. So this will be minus 6 microcoulomb. So your final charge will be this. And your initial charge will be, that is your B1, it is given to you minus 7 micro coulomb, and B2 it is given to you 4 microcoulomb, and the third charge, let this be charge, that is X is equal to minus 6 microcoulomb. So this will be how much? Minus 3 and minus 3. So minus 3, there will be again plus 3. So X will be equal to minus 3 microcoulomb. This is your answer. This is your answer. Because your charge is conserved. Remember, your charge is conserved. Your charge is conserved. And it gets redistributed among themselves. A circular loop A of radius r carries a current I. Another circular loop B of radius r, that is r by 20, is placed concentrically in the plane A. The magnetic flux linked with loop B is proportional to. That means here this is loop A and concentrically another loop B. Yes, we have to find the Magnetic flux linked with the loop B, this one B. Magnetic flux linked with loop B, we have to find this. We know that the magnetic flux at the center of a circular loop, magnetic flux, no, sorry, magnetic field, magnetic field at the center of a circular loop mu naught I by 2R, we know this. Magnetic field at the center of the loop is this. We know this, which you have calculated it or you have proved in Biot-Savart law. You have proved in Biot-Savart law, that is the magnetic field at the center of the loop is this much, mu naught I by 2R. And the flux link with B, phi B, will be the magnetic field at the center. This is the magnetic field. This is the magnetic field at the center. Magnetic field at the center. This is the magnetic field at the center. So flux, that will be this magnetic field into area of this loop, that will be pi r square. So this comes out to be mu naught I by 2r into pi, radius it is given to you, that is r by 20 the whole square. This is phi b. So here this will be phi b, that will be equal to, here you see all these are constant, all these are constant, here r and r square cancels out, so here you will get that phi b is proportional to r, phi b is proportional to r. So this is your answer. Now here figure, this is the relation between graph, that is inductive reactance and angular frequency. And we know that for uh, inductor or inductance, we know that the relation between XL and inductive reactance and frequency, we know that XL is equal to L omega. This is the relation we know between inductive reactance and angular frequency. We know this. So if you relate this with y is equal to mx, so here your slope will be, your slope is your L, inductance is your slope. Inductance is your slope, because these two becomes your variable and in this is the slope. So you have to find out the relation between L1 by L2. So slope of L1 is equal to 10 30 degree and the slope of L2 is 10 60 degree. So this is 1 by root 3 by root 3. So this will be equal to 1 by 3. So this is your answer. Here a coil of N turns is placed in a magnetic field B such that B is perpendicular to the plane of the coil. Magnetic field is perpendicular. B changes with time, where T is the time period. The magnitude of EMF induced in the coil will be maximum. And we know that phi is equal to NAB. That is the flux. We know that N, it is the number of turns, A is the area of the coil, B it is the magnetic field. We know this. So here this is phi, B value is given to you, that is N A B naught cos 2 pi by T. This it is given to you. And we know that induced EMF, that is equal to minus d phi by dt. So if you differentiate this, you are going to get this, if you differentiate this, you will get n a b naught, cos it will be minus sine 2 pi by t into t, because there is chain rule, so into 2 pi by t. So you are going to get this minus. So minus minus plus, this will be n a b naught, and here this is sine 2 pi by t into t, and then again 2 pi by t. You are going to get this result. And this EMF will be maximum when this sign, this value of sine is 1, that is its value of sine is 1 at when the value of sine is 1, that is sine uh, 2 pi by t. I'm writing it in short. That means this angle must be 90 degree. 2 pi by t is equal to into t, that will be equal to pi by 2. So here pi cancels out, so t will be t by 4. So it will be maximum at t is equal to t by 4. Here two charged particles P and Q having the same charges but different masses, MP and MQ starts from rest and travel equal distances in a uniform electric field E in time Tp and Tq respectively, neglecting the effect of gravity, the ratio Tp by Tq, you have to find it out. We know the relation for charge, we know the relation between force and electric field, that is equal to QE. We know this. Force is equal to QE. And your acceleration of the charged particle, that is F by m, QE by m. Now, you have to find the time. So distance travel, as initially it is initially at rest, so S is equal to initially it is rest, so it is half ut plus half at square. So this is a QE by m into t square. So from here we get 2Sm by QE is equal to t square. From here we get this. Because they starts from rest and travels equal distances. The two charges travel equal distances, means your distance is constant, mass is constant, charge is constant, and your electric field in a uniform electric field. Uniform means your electric field is constant. So from here we get that T is proportional to root m. From here we get that T is proportional to root m. So we know the relation between force and electric field. The uh, force exerted on a charge q placed in an electric field. We know that the force exerted on a charge q placed in an electric field. We know that the relation, that is F is equal to QE, and we know the acceleration F by m, and S is equal to ut. So initially it is at rest, so u is 0, so half at square, and we know that they travel equal distances, that means distance is constant and uniform electric field, therefore E is constant, charge is constant, mass is constant, so T is proportional, your sorry, distance constant, Q is constant, electric field is constant, equal distances, distance constant, uniform electric field, E is constant, but they are of different masses, so mass is not constant, so T is proportional to root m. So your Tp by TQ will be equal to root over MP by MQ. This will be the relation you are going to get. So this is the relation ratio you are going to get. So here in this question, uh, potential difference and drift velocity. So the relation between potential drift velocity Vd and potential difference is mobility into your potential difference. And we know that Vd is equal to, sorry, electric field. Electric field. We know that drift velocity, that is mobility into electric field, and we know that electric field is V by L. And we know that electric field is into V by L. So here we see that Vd is proportional to V. So if your means this is drift velocity, this is potential difference. Remember this. This is potential difference. So your drift velocity Vd, this is your drift velocity. This is your drift velocity. Drift velocity. So your drift velocity is proportional to potential difference. So when your if v reduces to v by d, their drift velocity will become, that means your drift velocity will also reduce by 2. So your drift velocity will become how much? Will be equal to v by 2. Your drift velocity also will be equal to v by 2. Here we know the relation between I is equal to E R plus R. This R is the internal resistance of the battery. We know this relation. So here this is 0.9 E. This for first case your resistance is 2 plus R. 0.92 plus R is equal to E. And for the second case, it is your current is 0.3, 0.3, that is equal to E by your resistance is 7. Because it is the same battery, uh, uh, one by one, because they are the same battery. So your this is actually induced EMF. This is induced EMF. Induced EMF. This is not E. This is actually induced EMF. So here your induced EMF, sorry, this is induced EMF, not E, induced EMF. So here you see, so your induced EMF will remain the same. So 0.37 plus R is equal to epsilon. So if we equate this to 0.92 plus R is equal to 0.37 plus R, and if you solve it, if you solve this equation, let me solve it. This is 1.8, so 0. We can write this as 9, 2 plus R, 3, 7 plus R. So this is 9 to the 18 plus 9R, 21 plus 3R. So this comes out to be how much? 9R minus 3R is equal to 21 minus 18. So 11 minus 8, 9, this will be 6R, and here this will be how much? 3, 18, 19, 20, 21, 3. So R will be equal to 1 by 2, that is equal to 0.5 ohms. This is your answer. Here we know that suitable viewing of relaxed eye. That means image is at infinity. Image is at infinity. So for this, your compound magnification is equal to tube length by focal length of the object piece uh, into minimum distance of vision by focal length of the eyepiece. Your minimum distance of vision is 25 centimeter and the tube length is 10 centimeter. So this is 10 and your object piece 1 25 and your focal length of the eyepiece is 2. So this is equal to 25 uh, into 25. So this is 125. 125. This is your answer. Because it is in the question, it is given for suitable viewing by relaxed eye. So so it will be image at infinity and magnification for compound microscope will be L, that is the tube length divided by focal length of the object piece minus minimum distance of vision by focal length of the eyepiece. If you put the value, we get magnification 125.